Mastering API gateways. API gateways thrive on chaos, devouring traffic and requests with merciless efficiency. Where do its load balancing and scaling capabilities come into play to ensure the API gateway can efficiently handle high traffic and large volumes of requests while maintaining operational excellence and minimizing latency, errors, and downtime? To ensure operational excellence and minimize latency, errors, and downtime, an API gateway must possess robust load balancing and scaling capabilities. These capabilities are critical in handling high traffic and large volumes of requests efficiently. Load balancing, in this context, involves distributing incoming API requests across multiple back-end instances or services to optimize resource utilization, improve responsiveness, and ensure fault tolerance. A well-designed load balancing strategy can significantly reduce the likelihood of overloading individual instances, resulting in improved system availability and responsiveness. There are several load balancing strategies that can be employed, including 1. Round robin. Each incoming request is routed to the next available instance in a predetermined sequence, ensuring equal distribution of traffic across all instances. 2. Least connection. Incoming requests are directed to the instance with the fewest active connections, ensuring optimal resource utilization. 3. IP hash. Each incoming request is routed to an instance based on the client's IP address, ensuring that requests from the same client are consistently directed to the same instance. 4. Geolocation. Requests are routed to instances based on the client's geolocation, enabling proximity-based routing and reduced latency. 5. Session persistence. Requests are routed to the same instance that handled the initial request, ensuring session consistency and persistence. To ensure scaling, an API gateway should be able to dynamically adjust its capacity to match changing traffic patterns. This can be achieved through 1. Horizontal scaling, adding or removing instances to match traffic demand, ensuring optimal resource utilization and minimizing the risk of overload. 2. Vertical scaling, increasing or decreasing the computing resources, e.g., CPU, memory, allocated to individual instances, enabling efficient handling of variable workloads. 3. Auto-scaling, dynamically adding or removing instances based on predefined rules, such as CPU utilization or request latency, to maintain optimal performance and efficiency. In addition to load balancing and scaling, an API gateway should implement several other operational excellence strategies to minimize latency, errors, and downtime. These include 1. Content caching, storing frequently accessed content in memory or cache layers to reduce the number of requests sent to back-end instances, improving responsiveness and reducing latency. 2. Request collapsing, merging multiple identical requests into a single request, reducing the load on back-end instances and improving system efficiency. 3. Rate limiting, restricting the number of requests from a single client or IP address within a specified time window, preventing abuse and denial of service attacks. 4. Traffic shaping, regulating the rate at which requests are sent to back-end instances, preventing overload and ensuring consistent performance. 5. Monitoring and analytics, providing real-time visibility into API performance, traffic patterns, and system health, enabling data-driven decision-making and swift issue resolution. 6. Fault detection and isolation, implementing mechanisms to rapidly detect and isolate faulty instances or services, ensuring minimal impact on overall system availability and responsiveness. 7. Backup and recovery, maintaining redundant systems and implementing automated backup and recovery processes to ensure business continuity in the event of failures or disasters. 8. Continuous integration and deployment, automating the build, test, and deployment of API gateway code changes, ensuring rapid and reliable delivery of new features and bug fixes. 9. Security and access control, implementing robust security mechanisms, such as authentication, authorization, and encryption, to protect the API gateway and backend instances from unauthorized access and malicious attacks. By implementing these load balancing, scaling, and operational excellence strategies, an API gateway can efficiently handle high traffic and large volumes of requests while maintaining optimal performance, minimizing latency, errors, and downtime, and ensuring the highest level of operational excellence.